Structural Continuity of Innovation Across Three Industries and for Decades Part 2, number 1588, the 6th of April 2026, Gerald C. EclaireMD Foundation, Category, Scientific Methodology. Stroke is structural failure event. When I reviewed more than 100 CT images in my Stanford stroke chairman's office, I observed numerous white spots indicating my cerebrovascular calcification. These calcified regions represent structural stiffening of my brain vascular tissue over the past 3.5 decades of diabetes damage. At that moment, through a detailed viscoplastic energy analysis of my past 36 years of data points, I realized that much of this structural damage, 91%, originated during the 2-decade period from 1999 to 2009, when my type 2 diabetes was treated primarily with medications without sufficient lifestyle intervention. Using my viscoplastic energy model, I estimated that this 20-year period contributed approximately 91% of my total accumulated stroke energy that resulted in the event on June 21, 2025. The following 16-year from 2010 to 2025 contributed approximately only 9%. Aging alone does not explain this difference because aging occurs continuously in all individuals. The dominant factor was prolonged metabolic stress earlier in life. In other words, the structural damage was overwhelmingly determined by earlier life, not by aging. Once vascular calcification occurs at the cellular level, reversal becomes extremely difficult. Therefore, prevention of acute hypertension, the stroke-triggering condition, becomes critical. On June 21, 2025, an acute blood pressure spike of 175 mmHg triggered a hemorrhagic stroke in the pontine region of my brain. I am not a chronic hypertension patient. The triggering event was associated with a short burst of emotional stress during a real estate negotiation. This personal experience demonstrated clearly that emotional stress can produce measurable mechanical consequences in the vascular system. After this event, I transferred financial management responsibilities to my children in order to reduce exposure to acute stress triggers. Scientific meaning of self-observed longitudinal data. Through my research experience, I have learned that biological truth exists independently of institutional hierarchy or statistical convention. Population-based statistics describe average behavior across groups. However, individual system dynamics determine personal risk. By studying longitudinal personal data, I shifted from being only a patient to becoming an observer of my own biomedical system. Extreme values, such as peak glucose levels or acute blood pressure spikes, often drive structural damage. Statistical averaging can mask these critical events, yet statisticians frequently classify them as outliers and therefore ignore their physiological significance. Scientific truth does not change to accommodate convenience. If calcified vessels become less elastic and more vulnerable to rupture under acute blood pressure spikes, then analysis based solely on average blood pressure values is incomplete for certain individuals, particularly those with severe health conditions. My confidence in science is not blind belief. It is based on repeated hypothesis testing and observation of consistent patterns. Engineering confidence develops when system behavior can be predicted reliably under defined conditions. Similarly, biomedical understanding can improve when high-resolution longitudinal data reveal consistent cause and effect relationships. No.1588 collaboration. My current medical research workflow integrates natural intelligence and artificial intelligence. Human cognition contributes conceptual understanding, structural reasoning, and pattern recognition. Artificial intelligence assists with writing, organization, editing, and computational efficiency. This collaboration improves productivity while preserving scientific direction. After my stroke, I produced 280 research papers about stroke within 280 days. This productivity reflects continuity of cognitive structure developed over decades. My previous experience in semiconductor routing also connected to understanding patterns of neurons and neural pathways within the human brain. Electrical pathways in chips and neurosignal pathways in neurons share structural similarities. Essentially, AI is a natural extension tool of my structural reasoning because it handles pattern repetition, results amplification, and organization of the patterns recognized by human cognition. Toward deterministic preventive medicine, my current research focuses on development of deterministic tools for early detection of chronic disease risk. The Stroke Triggering Sensitivity Index (TSI) models interactions among three primary physiological variables, SBP, DBP, and EEG. Using simple multiplicative relationships, interaction among variables often produces amplification effects. This structural principle applies across many physical systems: portable computing, anticipatable technology, semiconductor design, anticipated neural architectures. Deterministic biomedical modeling may contribute to the next generation of preventive medicine. Future medicine may become more continuous, physics-based, and personalized. Conclusion: across for decades, my work reflects continuity of a single scientific perspective. Structure influences behavior. Energy accumulation produces transformation. Interaction among variables produces nonlinear amplification. Time determines cumulative damage. The stroke I experienced did not weaken this scientific direction. It clarified the importance of understanding the biomedical system through structural reasoning. Scientific truth remains independent of disciplinary boundaries. Understanding structure improves prediction. Prediction improves prevention. Prevention extends functional lifespan. This continuity of reasoning connects portable computing, artificial intelligence-based semiconductor chip design, and neuroscience of medicine within a unified scientific framework. Truth remains the central guiding principle, in every system one has studied. Truth emerges only when structure is understood and the methodology is rigorous enough to expose it. Epilogue: my transition from the Pied Piper 1980 to semiconductor and 1994 to biomedicine 2010, including neuroscience 2025, is a class of first principles thinking. I am not just jumping between industries. I am applying the laws of thermodynamics and structural mechanics to different containers. In 1982, the container was a plastic and metal PC chassis. In 1994, it was a silicon wafer. In 2010, it became the human vascular system. In 2025, it culminated in neuroscience of stroke. The insight that connectivity networks and EDA tools mirror neural pathways is particularly striking. It suggests that efficiency, whether in electrons or neurotransmitters, follows universal math phi. Cycle and topological truths. Disclaimer: I write this paper not for fame, but to share what I have learned so others can understand their health, prevent disease, and live longer, healthier lives. This content is provided for educational reference only and does not constitute medical advice. No. Doctor-patient relationship is created. You may share this summary freely, but it must not be altered, edited, or republished as your own. All intellectual property rights and copyrights for this article and its related materials belong to T. E. Author, Gerald C. This content is provided for educational reference only and does not constitute medical advice. No doctor-patient relationship is created. You may share this summary freely, but it must not be altered, edited, or republished as your own. All intellectual property rights and copyrights for this article and its related materials belong to the author, Gerald C.